Alright, you guys, listen, I'm going to do a couple examples here. So, this is one type of problem that deals with continuity, and it'll say what value of k will make this function continuous. Alright, what value of k will make this function continuous. So, for a piecewise function to be continuous, the two equations have to be equal to each other, right? When you plug in that x value. So that's all you do, is you set these equal to each other, you plug in the x, and solve it for k. And that tells you what k will make this continuous. So we're going to say kx plus 5 equals x squared minus 2, because we want them to be equal to each other for it to be continuous. We're going to plug in 1 for whatever this is over here for x. We're going to plug that in for x. So we should have k plus 5 equals 1 minus 2. So k equals -6. Alright? So k equals -6. That's the number that could go right here that would make this function continuous. Alright? So you set them equal to each other, plug in the x, solve for k. And on the problem you have it's an a that you got to solve for instead of a k. So it's just whatever that other variable is. Okay? Now remember that for on the middle section here, 25 to 30. Well, don't worry about number 30. You got to do.
Whoa!
Well, you can if you want. You got to do some synthetic division on that if you want.
No.
All right, but the other ones, listen. The directions say give a formula for the extended function that is continuous at the indicated point. What that means is what y value will fill in the hole there. That's what it means. Okay? So you do what we were doing the other day. You factor and cancel if you can and plug in the number, and that's the y value that should be there. So if we have like x squared minus 16 over x plus 4, x cannot be -4 there, right? X can't be -4. So the question would be what y value can we assign to -4 in order to fill in the hole that's there? Okay, so what you can do is just factor and cancel like we've been doing. So those cancel. Now we can plug in -4, right? And we get -8. That's the answer. That's the y value. But what they're saying is how you would write that is to turn this into a piecewise function. It's this function for x is not equal to 4, and it's the function -8 for x is equal to 4, and that -8 fills in the hole that would have been on the original function.
X is equal to 4, x is equal to
no, sorry, -4.
Okay,
yeah.
I was like, what?
Okay, sorry, yeah.
Okay.
-4. Those have to be the same, for sure. Okay, so that's what you're doing.
So the one that you're given is the first one.
Yeah, and you're just figuring out the y value you need to fill in that hole, okay, which is what you would get when you factor and cancel and then plug in that number, that x, okay. Now, there's a couple problems that have the sine x over x, and notice how 27 and 28 have sine x over x, and they're both x equals 0, and we have that special limit, right? That the sine of x, the limit as x approaches 0 of sine of x over x. You remember what that is? We did a whole section on that. 1, yeah. So that part of it, you got to just think, okay, well, the sine x over x part is just 1. So that's what the y value would want to be. Okay. And then there's a couple problems here. Don't worry about 39 and 40. But these other ones, I'm going to make these kind of bonus questions on the test to where you actually sketch something. Okay? So let's just say, I'm just going to make one up here. F of 1 exists, but the limit as x approaches 1 does not exist. Okay? So there's lots of different ways that you could draw that. But you just have to, if f of 1 exists, that just means there has to be something closed at 1 somewhere. Okay? The limit does not exist. Well, if the limit doesn't exist, there could be a jump, so you would just draw something like that, and that would take care of that. Okay? There'll be some that are using some are these ones on this are maybe a little more complicated. let's maybe do one of these. Let's just look at number 36.
36, yes.
So it says f of negative 2 exists. Alright, so at negative 2, we do have something. It says the limit as x approaches negative 2 from the right equals f of negative 2. So we have a closed dot somewhere. You can put it anywhere you want. But the limit as you approach from the right also equals that. So that means whatever, you got to come up to that point. Okay, it doesn't matter how you draw it up to that, but you got to come up to that point from the right. All right, and then it says, but the limit as x approaches negative 2 does not exist. So if we're approaching from the right exists, but the overall limit doesn't exist, again, you can fix that. We can do that with a jump. Yeah. Well, no. If it's because if it's an endpoint, then the limit actually would exist if it's an endpoint. So don't. So make sure you continue it somewhere else. Okay. So that's all, something like that. All right. Those will be bonus questions. So remember the difference between the function value, okay, and the limit. How could you have a limit exist but something not be continuous? The limit exists but something not be continuous. That could just be a hole. All right. The limit exists but it's not continuous. All right. So just you'll have I'll put 5 of those down and give you a point for each one that you can do right. I want you to do them on the same graph though. Okay. All right. So finish that worksheet up.